We've got some fresh images of 3I Atlas, a third ever interstellar object observed from Earth, currently racing through our solar system.
It's the kind of headline that grabs attention instantly. But here's the truth. No NASA whistleblower had to sneak photos out of a lab. The real images of 3I Atlas, the third known interstellar object, were captured, processed, and released openly through NASA, ESA, and ground observatories. What fuels these leak rumors is the comet's extraordinary nature, a cosmic visitor from another star system that has astronomers, the public, and yes, even conspiracy theorists paying very close attention. So what do we really know about 3I Atlas? Let's start from the beginning. A stranger from the stars. 3I Atlas, officially designated C/2025N1, was discovered on July 1st, 2025 by the Asteroid Terrestrial Impact Last Alert System, ATLAS, in Chile. Its orbit was quickly flagged as unusual. Instead of looping around the sun, its trajectory was hyperbolic. That's a cosmic signature telling astronomers this object comes from outside our solar system. At about 58 kilometers per second, 3I Atlas is moving too fast to ever be captured by the sun's gravity. It's simply passing through, making a brief cameo in human history before heading back into interstellar space. For context, this makes 3I Atlas only the third interstellar object ever detected, after 1I Oumuamua, 2017, and 2I Borisov, 2019. While Oumuamua looked like a strange cigar-shaped rock and Borisov behaved like a fairly normal comet, 3I Atlas offers something different again. A hyperactive comet with a coma and tail already visible at a great distance. NASA's first official look, Hubble images. Shortly after discovery, astronomers raced to aim their most powerful tools at the object. The Hubble Space Telescope locked onto 3I Atlas on July 21st, 2025, when the comet was about 277 million miles, 445 million kilometers from Earth. The Hubble images showed a clear coma, a glowing envelope of gas and dust boiling off the comet's icy nucleus. This coma was already 26,000 kilometers wide, roughly twice the diameter of Earth. That's massive, especially considering the nucleus itself is estimated to be less than 1 kilometer across. In other words, this tiny cosmic snowball is wrapped in a shroud of gas larger than our entire planet. These first real images instantly went public through NASA's official website, Hubble news releases, and astronomy archives. Yet within hours, social media began buzzing with claims that the true images were being hidden. Why? Because the photos didn't look like Hollywood's glowing comet art. They were faint, grainy, and scientific. The gap between expectation and reality helped fuel the NASA insider leak narrative. Ground-based observations, Gemini South Telescope. Meanwhile, back on Earth, the Gemini South Telescope in Chile joined the chase. Gemini's adaptive optics produce sharp ground-based images, confirming the size of the coma and giving a slightly different perspective than Hubble. These observations were key because they showed rapid activity, suggesting the comet's ices were unusually volatile. Astronomers noted that while most solar system comets release mostly water vapor near the sun, 3I/ATLAS appeared to be releasing carbon dioxide and carbon monoxide at large distances. This hinted at a chemistry different from what we're used to, a clue that it formed in an environment unlike our own solar system. Again, the images and data were shared openly, published through scientific channels, and even covered by mainstream media outlets like Sky at Night and Live Science. But the moment you mix interstellar object, strange chemistry, and fuzzy space photos, you get the perfect recipe for online theories of censorship. The power of the leak narrative. So why do people jump to the idea of a NASA insider leak? The answer lies in psychology. Whenever space agencies release official data, the images are processed for clarity, often in black and white or infrared. To scientists, these are pure gold, To the public, they sometimes look underwhelming until someone reposts them with a dramatic color filter and the caption, "NASA won't show you this." In truth, NASA operates with radical transparency when it comes to interstellar objects. Both the raw and processed images of 3I/ATLAS are available on official servers. But in an era of social media virality, the idea of a secret shutdown story spreads faster than careful scientific press releases. Why this matters. Whether people call them leaks or official releases, the fact remains, humanity now has its first real images of 3I/ATLAS. These photographs, combined with spectroscopy and orbital data, allow scientists to study material forged in an alien solar system billions of years ago. It's not just about a comet, it's about understanding planetary diversity across the Milky Way. Every volatile molecule boiling off 3I/ATLAS tells a story about where it formed, what kind of star system it came from, and how universal or unusual our solar system really is. And that's why these images are so historic. They're not leaks. They're the beginning of a new chapter in our understanding of interstellar chemistry and astrophysics. The hype versus reality. NASA insider leaks first real 3I/ATLAS images live and gets shut down. That's the viral headline. But by late August 2025, NASA wasn't shutting anything down. In fact, it was doubling down with even more data. The James Webb Space Telescope, JWST, humanity's most advanced infrared observatory, had turned its powerful mirror toward 3I/ATLAS. What it revealed didn't confirm any secret alien probe theories, but it did show chemistry unlike anything we've seen in most solar system comets. Webb's infrared observations, August 2025. On August 25, 2025, JWST observed 3I/ATLAS in the infrared spectrum, which is perfect for detecting gases that aren't always visible in optical light. Its instruments revealed a cocktail of volatile compounds. Carbon dioxide, CO2, present in much higher amounts than typical comets near Earth. Water vapor, H2O, confirming ice sublimation, a standard cometary trait. Carbon monoxide, CO, released at relatively high levels, showing that the comet's ices formed in extremely cold conditions. Hydrogen cyanide, HCN, a common but toxic comet gas. Atomic nickel vapor, Ni. And here's where it gets strange. No corresponding iron vapor, Fe, was detected. This last finding puzzled scientists. In solar system comets, nickel and iron are usually found locked together in dust grains. Seeing nickel vapor without iron vapor suggests a different thermal or chemical history, possibly a process unique to the comet's home star system. A comet that doesn't fit the mold. Astronomers now classify 3I/ATLAS as a hyperactive comet. Unlike many long-period comets that only begin significant outgassing when they're closer to the sun, 3I/ATLAS was already venting huge amounts of gas far out in the solar system. The JWST data confirmed what ground-based telescopes like Gemini had hinted at. This comet carries a different mix of ices, probably preserved from the earliest days of its home planetary system. That's important because it means we're looking at primordial material from another star's nursery, untouched for billions of years until it wandered into our view. Why people think the images are leaked. If NASA and JWST data are openly shared, why do so many headlines scream about insider leaks or shutdowns? Here are 3 reasons. 1. Expectations versus reality. The public expects high-definition, colorful images like those of Jupiter or the pillars of creation. Instead, JWST and Hubble often release scientific images, infrared data plots, black and white captures, or composite false color visuals. To the untrained eye, they look underwhelming. That gap sparks suspicion. 2. Social media amplification. Within hours of JWST's 3I/ATLAS release, users on X, Twitter, TikTok, and YouTube began claiming NASA isn't showing us the real thing. Some reposted the same official images but with filters, calling them leaks. 3. The mystery factor. 3I Atlas isn't just another comet. It's a visitor from another star system, and people are naturally drawn to mystery. When something feels extraordinary, it's easy to imagine governments hiding part of the truth, even when the real science is already public. Open science, how NASA really handles it. In reality, NASA follows an open data policy. The JWST data on 3I/ATLAS, including spectra and processed images, is stored in the Mikulski Archive for Space Telescopes, MAST, available to any researcher or member of the public who wants to download it. Far from hiding the data, NASA actively publicizes interstellar discoveries. Just like 1I/Oumuamua and 2I/Borisov, 3I/Atlas has been covered in press conferences, public releases, and peer-reviewed papers. If anything, NASA has the opposite challenge, trying to explain complex data in a way that captures the imagination while staying accurate. The real story the data tells. Rather than a shutdown, the web images give us a window into questions like, where did 3I/ATLAS come from? Its high velocity, 58 kilometers per second, suggests it was ejected from its home system by a violent gravitational interaction, maybe a passing star or giant planet. What does its chemistry reveal? The carbon monoxide and nickel vapor point to an origin in a much colder, perhaps more metal-rich environment than our solar system. How unique is it? By comparing 3I/ATLAS with Oumuamua and Borisov, astronomers can start to map the diversity of interstellar debris across the galaxy. Every molecule escaping from 3I/ATLAS is like a postcard from another world, telling us about conditions light years away. What the leak means for the future of space science. The supposed leak of the first detailed 3I/ATLAS images and NASA's rapid shutdown of the stream raises an important question. How will humanity handle the discovery of interstellar objects going forward? This is not just about one event. It's about the future of space science, transparency, and the balance between security and discovery. Lessons from Oumuamua and Borisov. To understand where we're headed, it helps to revisit the past. When Oumuamua streaked through the solar system in 2017, it left the scientific community both excited and frustrated. Excited because it was the first confirmed interstellar visitor. Frustrated because by the time telescopes locked onto it, the object was already on its way out. We got only weeks of data, with no chance to send a spacecraft. 2 years later, 2I/Borisov offered another opportunity, but again, we were unprepared. The comet's chemical composition told us it resembled our own comets, but the chance to study it in detail was fleeting. The leak of 3I/ATLAS imagery, even if brief, highlights that we may finally be on the cusp of better preparation. Governments, space agencies, and private companies now know that more interstellar visitors are coming, and this time they may want to capture them, literally. Interstellar object missions. One of the most exciting developments is the proposal of dedicated missions to intercept interstellar objects. ESA's Comet Interceptor, launching later this decade, will wait in space for a target, whether it's a pristine comet or an interstellar visitor. NASA researchers have floated concepts for a rapid response spacecraft that could launch within months of detection, capable of reaching objects like 3I/ATLAS. Some private space entrepreneurs argue for space intercept fleets, ready-to-go probes stationed in orbit, able to chase down these cosmic messengers. If the leaked images truly showed surface detail of 3I/ATLAS, then scientists now have motivation to argue even harder for such missions. Every interstellar object is unique. Catching just one up close could revolutionize our understanding of how other star systems form. The push for public data. The other major issue raised by the leak is transparency. Why should high-resolution imagery of an interstellar visitor be restricted? Advocates of open science argue that 1. Public funding deserves public access. NASA is taxpayer-funded, so its discoveries should be openly shared. 2. Collaboration accelerates science. The more eyes on the data, the faster errors are caught and insights gained. 3. Citizen science is powerful. Amateur astronomers already play a huge role in tracking asteroids and comets. With open access, they could help refine trajectories or even spot unique features professionals miss. But on the other side, NASA must navigate international politics. High-resolution space imaging often overlaps with military surveillance capabilities. The same satellite that captures 3I/ATLAS could also monitor Earth, and revealing its full resolution could expose U.S. intelligence capabilities. This is the core dilemma: balancing global scientific curiosity with national security. The future of interstellar astronomy. Looking forward, it's almost certain that the number of known interstellar objects will rise dramatically. The Vera Rubin Observatory in Chile will begin operations soon and is expected to detect dozens of new visitors each decade. That means 3I/ATLAS is not the last. It's just the beginning. Imagine a future where specialized spacecraft are pre-positioned to intercept visitors within weeks of discovery. International coalitions share data openly, pooling resources to maximize learning. AI tools rapidly reconstruct high-resolution models of interstellar bodies from faint telescope data. The leaked images of 3I/ATLAS may have been suppressed, but they hint at a near-future reality where we can finally see interstellar worlds in detail. What if life's ingredients are found? One of the biggest scientific questions surrounding interstellar objects is whether they carry the building blocks of life. Organic molecules have already been found on comets in our solar system. If 3I/ATLAS or future visitors show evidence of amino acids, sugars, or complex chemistry, it could be a game changer. It wouldn't mean aliens are sending probes. It would mean life's raw ingredients are widespread across the galaxy. That, in turn, strengthens the idea that Earth is not unique, and life could emerge in many other star systems. For this reason alone, astronomers argue that studying interstellar objects is one of the most important frontiers of space exploration. Final thoughts: the leak as a wake-up call. While the live leak of 3I/ATLAS images may have been brief, its impact lingers. It shows us three things. 1. Humanity is deeply curious about interstellar visitors. 2. The balance between open science and classified technology remains unresolved. 3. We are entering a new era where interstellar astronomy will no longer be rare. It will be routine. The shutdown of the leak doesn't erase the fact that we are capable of capturing these images. The technology exists, the discoveries are real, and the next time an interstellar traveler enters our solar system, the world may not settle for blurry dots of light.